Welcome back, everyone. Let's begin exploring an example of coding out k-means with Python and scikit-learn. In part one, we're just going to have a little bit of exploratory data analysis to get familiar with the data set we'll be working with. Let's head to the notebook. Okay, here I am at the notebook, and we're going to be using a modified version of a data set from the UC Irvine machine learning repository known as the bank marketing dataset. And essentially, it has a bunch of different features about bank clients. And what we want to do is see if we can just cluster these into some sort of grouping and try to better understand how k-means clustering works from an operational standpoint. So this data set is in the data folder, and I've already done my imports of NumPy, Pandas, Matplotlib.pyplot, and Seaborn. And I'm going to say df is equal to pd read CSV, and then in the data folder, I'm going to read in bankful.csv. Okay, let's check out the head of this data frame to get an idea of what we're working with here. This is a bunch of feature information about bank clients, and we can see here we have some continuous columns like age, some categorical ones like the type of job they have, housemaids, administrative, services, etc., marital status, married or single, education, whether they went to high school, basic 4-year, etc., whether or not they've defaulted on a previous loan, housing, whether or not they have a loan, and then some information based off the last time they were contacted in some sort of marketing campaign. So for example, there's an actual ID for that campaign they were marketed, how many days it's been since they were marketed to, the last month, and how they were contacted for that last campaign, etc. And you can check out the link in the actual lecture notebook for full descriptions of each of these features. What we're going to do now is just do a little bit of exploratory data analysis. Again, I would encourage you to check out the lecture notebook, which has full details on each of these features with full description. So what we're going to do is just check out a little bit more here. We can say something like df info to get an idea of how many rows we have. So we have quite a bit of data, about 41,000. And note here that we have both these integers, the objects, which are essentially the strings, and then some floating point continuous values. And what we can also do is say something like df.describe just to get an idea of the continuous features and how those tend to be distributed. So we can see here, as far as the age, the minimum is 17, and that makes sense because based off this bank marketing data, it's from kind of a European bank, so the absolute minimum age for these people to start getting marketed to for things like whether or not you're going to get a loan, it makes sense that the minimum age is something like 17. But we can see there's actually quite an old person in the data set, 98 years old, so it'd be interesting to see if people would actually convert based off that age. But we can see things like duration, campaign, number of days since they've been contacted, and then previous, etc. And then a bunch of different indices that you can check out yourself in the descriptions. So what we're going to do here is just do first a continuous feature analysis. So I would always encourage you, when it comes to clustering data, by definition, you do not have labels. So you really need to do two things. One is either do the research so you can have domain experience, or contact somebody that has domain experience to further explain the features to you. Domain experience and just general knowledge of the data set and the domain it lies in is a huge part of unsupervised learning. Since there's no 100% correct answers, we really are just in an exploratory mindset. And then number two is just to perform a lot of data visualizations to get a handle and feel for what the data actually looks like. So since we're not really domain experts in bank marketing, and I can't really call someone right now to ask them about this data set, what I'm going to do is just skip forward to the data visualization portion. So let's go ahead and check out some of these continuous feature columns, such as the age column. And I'm going to say data is equal to df, and x is equal to age, using Seaborn and a hist plot for a histogram. That should show me the distribution. And we'll say plt figure. Let's make this fig size a little larger so it looks nicer here. Say 12 by 6, as well as a higher DPI. So what we can do here is check out the histogram. And it looks like most people are going to be between the ages of around 30 to 40. And you can see that it almost looks like these are separated out into cohorts. So you see these kind of blocks where no one is being marketed to, who, for instance, is around 29. What you could do is play around with the bin size to try to change that. So you can say a number of bins is something like, for instance, 30, and then you're not going to have any missing points. It just so happens to be that the default bin size kind of matched up with those particular values. So you get those kind of large chunks. But keep in mind, you could always edit this bin size to get a more generalized trend. And you can also say KDE is equal to true in order to see some sort of kernel density estimation plot. And again, we see here that the vast majority of people that were previously marketed to in this particular bank client marketing data set are around between 30 and 40 years old, which makes sense. That's probably around the time these people are going to maybe need to take out a loan or a mortgage. And what we can do here is if you check out the rest of the features and do a little more analysis on, for instance, what columns are available to you, you actually have information on whether or not that person currently has a loan. So maybe the overall tactic here for unsupervised learning is just to cluster these customers and see whether or not a cluster of customer could be someone we can market to. There's really no clear 100% objective in this unsupervised learning process because there's kind of no right answer to begin with. It's just trying to get further and deeper insights into our data set. So what we can do here is check out our data. And what I'm going to do is let's remove this KDE and make the bins a little more, maybe something like 40. But then I'm also going to say hue is equal to the loan column. So I can separate this out and see two distributions, actually three technically, whether or not they have a loan, so no loan, yes loan, and then unknown loans. And this could also kind of start indicating maybe there's three clusters here. The people that don't currently have a loan, the people that do have a loan, and kind of unknown for whatever reason we don't know in this data set. And you can see the majority of people do not have a loan. And that could be another indication that if you're dealing with this for the purposes of marketing, maybe you don't want to market to people that already have a loan because they're probably not going to take another one. So what you do is separate out everyone that does not have a loan and then start clustering that data instead to try to gain insights that way. Again, there's no right answers here. It's really up to you to explore and think about the domain and what makes sense. And in some industries, they might actually specifically target the people that already do have a loan because they've been shown to convert, so to speak, and maybe they're going to be a better client for actually trying to deliver some sort of product to them as far as a banking product or service. What we can also do here is check out the P days. So if we come back up here, you'll notice there was a P days feature. And that feature, if you check out the description, is the number of days that have passed by after the client was last contacted from some sort of previous campaign. And you'll also notice that if you check out the feature description in our lecture notebook, that 999 means the client was never previously contacted. So we have the previous number of days since the last contact from a marketing campaign, but recall that if you actually see here, the max value is 999, and that's actually a filler, meaning that person has never been contacted in any previous campaign. So if we actually were to plot that out in some sort of distribution, for example, let me delete hue loan here, and instead of age, I'm going to say P days, so number of days that have passed since the last marketing campaign. If you were just to do a histogram of this without reading the actual feature descriptions, you would get this confusing distribution where there's a few people over here on kind of a small amount of days and then a ton of people at 999. But remember, here, this is a filler code for people that have never been contacted. So right off the bat, you can see that most people have not been previously contacted by a marketing campaign. So in order to actually gain some sort of insight, what we could probably do is shrink down our X limits or just drop everyone that is equal to 999 because we know they don't technically count here. It's kind of up to you however you want to do this. So again, the two ways are to say data and then say df where df of the P days column here is not equal to 999. So this is one way to do it where you can just edit directly what data set you're actually passing into Seaborn. And if you were to run that, you would then get something that looks like this. And you can see the distributions there. Or what you could do is also say something like PLT xlim from 0 to something like 100 days, etc. So it's kind of up to you how you want to solve this problem. But something else to note here is we should probably not ask for that many bins and try to see if Seaborn can figure out the ideal number. It looks like, based off previous campaigns, most people have only had maybe somewhere between 3 and 10-ish or 7-ish days that they've been contacted here. But we already know from our original distribution that most people have never been contacted. So everyone in here is actually the vast minority. Note here, we're only going up to 400, but recall there was over 40,000 people in this entire data set. Okay, so now let's move on and start thinking about contact duration. If you check out the feature set, there's actually a feature called duration, which is when they were last made contact with, that is, when the customer, we last had contact with them, how long did their interaction actually last? So if we check out df contact and ask for the unique values available, there is telephone and cellular, essentially saying, did we contact them on a landline telephone or through a cell phone? And then what we can also see is if we take a look at duration, and I'm not going to call unique here because duration is a continuous column, it's actually how many seconds did we actually have that last contact last. So 120 seconds would be a 2-minute telephone call, for example. What we're going to do is check out the distribution of this. And we could do this just by coming back up to our histogram. Since we're dealing again with a continuous thing, I'm going to say data here, or df, and then x can be duration. And I can see the duration here in seconds. Note that for whatever reason, there was one case, or maybe a few cases, that had super long duration times, so over 2,000 seconds. Which, keep in mind, 1,000 seconds is about 16 minutes. So 2,000, you're talking about over half an hour of contact. And it makes sense that the vast majority of people are somewhere between 0 and 1,000 seconds. So most people, you're talking to them between 0 and even like the 10-minute mark. What we can do is separate this out further based off whether they're telephone or cellular. So we can say hue is equal to contact, which actually describes how they were contacted, either like a landline telephone or a cell phone. And notice here, the distribution is pretty much the exact same. It's just that cellular is a higher count than telephone, but the behavior of the distribution, that is the curves themselves, are actually extremely similar. And you can check this out further by manually editing the x limits. So I can say only go from 0 to 1,000, so all the calls that were kind of from 0 seconds to about 15 minutes. And again here, you're seeing extremely similar behavior, regardless whether or not they were contacted through telephone or a cell phone. And so what's the actual insight we can glean from this is that there's probably just more people that are giving their cell phone rather than a landline telephone. Makes sense as time goes on, your cell phone is kind of your personal telephone. Okay, so what we can also do is start doing things like checking out categorical data, or categorical features, along with the idea of checking out continuous features. So maybe we start thinking about distributions between categories. And one last thing we can do is just kind of confirm this idea that there's just going to be more people with cell phones than telephones with a simple count plot. I can say SNS count plot, data is equal to df, and say x is contact. And it pretty much gives you the same visualization here. There's just more people with cell phones than telephones, and it doesn't really matter if you're going to contact them through the cell phone or telephone. The distribution of how long the call lasts is roughly the same between them. So whether or not you're kind of talking to someone on a cell phone or landline, the average call time doesn't really make a difference either way. It's just more people have cell phones, which is why it looks a little different between them. Let's move on to categorical features a little further. What we can do is just check out the types of jobs people have. So recall from our data frame, there is this job column. So what would be nice is maybe create a bar plot, and we can check a count of the different job types. So I can say count plot, data is equal to df, and then say x is equal to job here, and run that. And we can see here the jobs, but it's a little sloppy just with the defaults. What I want to do is probably rotate these x ticks. So let's do that. We're going to say plt x ticks, and we can do this with rotation is equal to 90 degrees. It'll actually grab that label and put a semicolon here if you don't want to see all this text output if you're in Jupyter. Run this again, scroll down here, and you can see we've rotated this. Now, it's also not a very nice size, so I'm going to resize this. And I'm actually going to resize it using the same code we used above here, plt figure. Let's just copy this and paste it in. So we're going to scroll back down here and paste that in. make it look a little nicer. And there's one last thing I kind of want to edit. Right now, it's actually not really sorted. So what I can do is add in an order parameter. So if you do Shift-Tab on count plot, you'll notice that it actually has this ordering parameter. So I'm going to scroll down here, and you can see there is order in the actual parameter, so we can explore that as well. So order is just a list of the order the column should be in. So I can say order is equal to, and that's what I'm going to do. You're going to see this right now. I'm going to say df, and then say job, and then I can say value counts. Recall value counts, that's essentially this count plot. It's just numeric. And what I want to do is order it based off this index. So I can say df job value counts. That sorts it. And then I can say dot index. And that gives me this list. And this list is exactly what I pass into order here in order to sort this count plot. So I simply grab this, copy it, paste it in there, run this, and I have this nice looking bar plot now. So most people were admins, then we have blue collar workers, technicians, services, etc., with the minority of people just some unknown job. And that gives us this really nice plot, again, sorted. What we can also do is do the exact same thing for education, start exploring education categories. So X education, and then switch this out as well. Education. Again, now we're sorting by the education levels. So most people have some sort of university degree, and this is the highest level of education. Then below that is high school, and then maybe basic 9 years, professional course, 4 years, 6 years, some unknown, and then almost zero illiterate, or maybe there is just that random one person there. Okay, so that's the level of education there, and those are some categories. We're going to do just a couple more visualizations to get an idea. What we could do here is see whether or not there's some sort of relationship between their education level and whether or not they defaulted on a loan, which means I can come back up here and in count plot, scrolling over to the right, I'm going to say hue is equal to default. So in running this default per education plot, you'll notice that there actually are hardly any instances of people actually defaulting. It's actually just no default or unknown status. And this unknown status, if you check out the feature set and the feature descriptions, it really could be two things here. One, you don't actually know whether or not they've defaulted, or they're currently on a loan, and maybe you don't know whether or not they're going to default on that loan because technically that loan is still ongoing and it hasn't closed off into some sort of default. And you could check this again with a simple count plot by saying something like sns.countPlot data is equal to df, and just check, hey, how many people do we actually have in this value of unknown? And you'll notice there's essentially almost nobody with yes. And you can say df default and then do value counts here to confirm this. Run that, you know, it's just 3 people are the only people that you know for sure defaulted. Recall, the vast majority of these people maybe don't even have loans, so we can check that with loan. Run that, and most people don't have a loan. So it would make sense that most people that don't have a loan are not going to default on a loan because it's not one to begin with. So we have only 6,248 that currently have a loan. You have 990 that you don't know. And out of those 6,248, it looks like the vast majority have not actually defaulted on their loan. Only 3 of them, you know, for sure. So essentially, there's kind of no defaults in this data set yet. And lastly, what you could do is do a pair plot on the entire data frame. I should note that for a data frame this large, this could take a really long time, and depending on how much RAM you have on your computer, this could actually crash your computer. So just a word of warning here. If you have a lower tier computer, this may take a super long time, or your kernel could die. In that case, just select a few features you're interested in and start breaking it up that way. But it is sometimes nice to kind of see the entire grid. Of course, the categorical ones are going to appear kind of lines or 2 groupings here, but this just gives you kind of a really quick overview, and you can see sometimes some interesting patterns. Obviously, the plots themselves are quite small, so you probably want to choose just a subset of features to further analyze this. Okay, that's it for exploratory data analysis. Just wanted to get you start thinking about exploring data visually before you start going straight to something like an unsupervised clustering process. What we're going to do now is in the next lecture, switch to actually clustering this and getting the data set up for k-means clustering. I'll see you there.